electrochemistry. And electrochemistry basically involves the flow of electrons to cause a chemical change, or a chemical change that causes flow of electrons. So we'll have both of these things occurring during electrochemistry. So we're talking about batteries or even cells, hydrogen fuel cells, we're talking about lithium batteries, every kind of stuff. And it involves the movement of electrons and ions. So electrons and ions are moving and causing about these changes within the electrochemistry. We have electrochemical reactions, redox reactions. These are reactions that involve both oxidation and reduction taking place. And electrochemistry usually involves having a cathode, an anode, and an electrolyte. So the cathode is where reduction takes place, and an anode is where oxidation takes place, basically. And an electrolyte should be present to move the ionic charge. An electrochemical setup is where reactions will take place. So reduction plus oxidation reactions will cause redox reactions. So we're going to look at these redox reactions, and we'll see that oxidation involves loss of electrons, like we see sodium losing an electron, aluminium losing those 3 electrons, and sulfur losing those 2 electrons. So oxidation normally causes an increase in oxidation number, or the oxidation number gets more positive. For example, we can see nitrogen monoxide right there being oxidized to nitrogen dioxide. And what we see if you capture the oxidation state of nitrogen in nitrogen monoxide, it's slightly lower than the oxidation state of nitrogen in nitrogen dioxide. So when oxidation occurs, there will be an increase in oxidation number, or the oxidation number will get more positive. Now that will imply the nitrogen is getting oxidized. Now, for reduction to take place, there should be a gain of electrons. So there should be a gain of electrons, or maybe that is in this electrochemistry. If you read other texts or in other topics, we will see reduction occurring when there is addition of hydrogen or something like that, or loss of oxygen. But in this case, we're looking at gain of electrons. Now, if you see that nitrogen atom right there is gaining 3 electrons, forming that nitrogen ion right there. So that is reduction taking place. We're seeing nitrogen ion 3 ions being reduced to ion 2 ions. So there is a gain of electrons that you can see right there. And during reduction, there is a phenomenon that occurs, that is the decrease in an oxidation number, or the oxidation number gets more negative. So if you look at manganese in the permanganate ion right there, we're seeing its oxidation state being +7 or the +7, and when it gets reduced, it will be reduced to a +2. So there is a decrease in oxidation number, as we've just explained. Now we're going to look at the concept of redox reactions in this electrochemistry. So we're looking at half-cell reactions, which are fully balanced with respect to both atoms, masses, and electrons, and either reduction or oxidation half cell. So we'll have a reduction half cell and an oxidation half cell. So in this case, we'll have that compound right there is SN being reduced, so that is a reduction half cell. And then we'll have another one being another one being reduced, which is the iron 3 chloride also being reduced. So that's all occurring at the reduction half cell. And then we have something that is happening at the oxidation half cell. So there is that manganese to iron that is being oxidized to a permanganate. So that one will be written on the side of the oxidation half cell. So those are the half cells that we have in these reactions, but these half cell reactions don't occur by themselves in the real world. They all occur simultaneously with the other half. So it's the half cell reaction and then the other half cell reaction. All of them are occurring at the same time or simultaneously in what we call the redox reaction. So there are components that are being reduced and components that are being oxidized. So hence redox reactions are occurring both simultaneously in a chemical reaction. So the different types of electrochemical cells, we have the galvanic cell and the electrolytic cells. The galvanic cell is a cell that converts chemical energy to electrical energy through spontaneous redox reaction. So we'll see something called spontaneity. We're talking about spontaneity, something that is occurring on its own without any external pressure or energy or force that is acting on it. So we'll see in these galvanic cells, this is a cell we call these special cells. There is conversion of chemical energy to electrical energy. So there is a chemical reaction occurring that is producing certain energy that is then converted into that pushes the flow of electrons. So I was talking about electrical energy coming in this stem, and it's occurring in a spontaneous way. So there is production of electrical current, and it occurs when the Gibbs because when the Gibbs free energy is less than 0, and if the Gibbs free energy is less than 0 or negative, we will have the the potential of that cell to be greater than 0 and that formula of the Gibbs free energy relation is used in this aspect. Now the galvanic cell will have a common example, that is the lithium ion battery. The lithium ion battery is common in phones, mobile phones, and your mobile phone has a lithium ion battery. There are cars that are made of the electric cars, the EVs, that have lithium ion batteries in them. So it's very common. It's all the new batteries that are being used right now, but it is a very good battery. So I think this drawing has a problem, don't mind about it too much, but so we're going to have a look at this. It's a Daniel cell, it's a galvanic cell. This example of a galvanic cell, we have a lithium ion battery. Another one is the Daniel cell. So in the Daniel cell, we are seeing sodium ions here. Now we have zinc, the zinc solid being oxidized to zinc ions. So this is the oxidation. This is the oxidation half cell, and then the other is the reduction as well, because we are seeing copper being reduced to the copper solid. So this is what we're saying. So at the anode, what is occurring at the anode is zinc being oxidized, and at the cathode is the copper to ions are being reduced, and the overall reaction is written right there. So that's what I was talking about. So all these processes, all these reactions, all these equations are occurring simultaneously. Oxidation and reduction are occurring at the same time. And then the lithium ion battery is a common example of the galvanic cell, and that is very good. So we will have a look at we'll continue with electrolytic cells in the next video. So if you want to learn more of this electrochemistry, just subscribe and click that like button, and you can share in the comments what you would like me to teach. To be very helpful. Thank you.